Question 16. The diagram shows the positions of a phone mast P and a school S. Part A. Find the bearing of the phone mast from the school. Right, so we first need to draw a straight line from the school to the phone mast. So there's a straight line from the school to the phone mast. It's important, it says find the bearing of the phone mast from the school. So we're actually measuring from the school here, and we've got a north line positioned at the school. So we need to take our protractor and we need to position it so the centre of the protractor is on the school. We need to rotate it round so it's vertically. Now we can notice that we're naught all the way around from the naught on the north line from the outside scale round to 180 degrees. So we need to turn our protractor all the way around through 180 degrees. And we can then measure from the south line at the bottom, still measuring around from naught all the way around 90, 100 degrees. We're staying on the outside scale here. So our angle for our bearing, we've got 180 degrees plus 100 degrees, which is 280 degrees. Now we can check that by, if we measure from the north line anti-clockwise round triangle, so this time we're going to be on naught on the inside scale, we can see we've got an angle of 80 degrees there. So if we take that away, the protractor away, if we write on our angle in here is actually 80 degrees in here. So we can also check that by, if we have 360 degrees, if we have 360 degrees, subtract 80, we should get exactly the same answer of 280 degrees. So the bearing of the phone mast from the school is all the way around 280 degrees. Part B. Richard cycles from the school in a straight line on a bearing of 320 degrees. Draw a line to show Richard's route. Now 320 degrees we can either draw in a clockwise direction of 180 plus 140 degrees, or we can draw it as an anti-clockwise direction of 360 minus 320, which is 40 degrees. So with our protractor we're going to position that in the centre at S. And what we're going to do, we're going to start from 0, going to come around anti-clockwise from the north line, 10, 20, 30, 40 degrees. It would be exactly the same if we got 180 degrees this way down to the south line and measure on the outside from 0 round to 140 degrees. So we're going to measure and draw his route now. There, that is the line that denotes Richard's route, which is 40 degrees in anti-clockwise direction. Point 2 says mark a point X on the line where Richard is closest to the phone mast. So we've established that this is our 40 degree angle here. So that's on a bearing of 320 degrees. Now mark a point X on the line where Richard is closest to the phone mast. Now it'll be closest to the phone mast actually somewhere about here, and we can denote that by, it's the point, the shortest point from a point to his line is when you're at 90 degrees to it. So from point P at 90 degrees to that line there, we can now indicate that would be at 90 degrees and the point X would be there. Okay, because if we imagined if we actually drew a circle, radius P there, it would be a tangent to that purple line. So the shortest point is the perpendicular distance from P to X. Part 3, what should angle PXS be? PXS should be 90